All right, good day everyone. So this video is going to pick up from where the previous video left off and just discuss a few more details about using packages in R. Now, most of the packages that you install are going to contain a bunch of different functions. And when you call the package using the library command like we did in the previous video, every function within that package is going to get loaded. In other words, all of the functions are going to become accessible via R commands. However, sometimes you don't want to load all of the functions in a package. Sometimes you might just want to load one of them and, save your computer's resources for other things. And, to be honest, this isn't usually necessary, especially considering how powerful computers have become. But, sometimes you might want to make the functions and the other code that you write just be a bit more computationally efficient. So this might be something you want to do to kind of aid that. And we're going to attempt this using a package called gtools. So gtools is kind of an interesting package. It just contains a bunch of kind of miscellaneous functions for all kinds of various situations. And one of the functions inside this package is called odd. And what this function does is it just simply tells you whether a number is odd or not. So if a number is odd, the function will return a value of true. If it's anything else, like an even number or a decimal number, it's just going to return a value of false. So let's get rid of that. We don't need it just yet. So let's do this. Let's just generate a vector of some random integers. So we'll create an object, we'll call it nums. And to do this, we can just sample from a big we can just randomly sample from a big sequence of values here. So we use the sample function and we'll just grab a sequence, maybe like 1 to 666. And we'll sample 13 values from that. Run it and take a look at our numbers there. And let's suppose we want to know, how many numbers in this vector are odd numbers. So to kind of do that, we're first going to install the package that we want to use. So that's going to be the gtools package. So we'll install that just like we did in the previous video. But this time, we're not going to load it using the library function. Instead, we're going to isolate the specific function that we want to use. So we're going to isolate that odd function I was talking about. So first we say install.packages, say gtools, and you can see it installs pretty straightforwardly, takes no time at all. And then next, to isolate the function, we're going to first type the package name, followed by 2 colons, and then the function name. And then we can just simply insert our vector. And when we run that, you can see we get quite straightforwardly just the function telling us whether each number, in our vector is odd or not. And recall that in R, trues are equal to 1 and falses are equal to 0. So if we want to kind of easily determine how many numbers in our vector are odd numbers, we could, of course, just count the amount of trues that we have here, or we could save ourselves some effort and use the sum function. So we just say sum, run that, and you can see we have 7 odd numbers in our vector here. Now, one thing that's maybe worth stressing is that we haven't actually loaded this function in a way that permits us to repeatedly use it on its own. So for instance, if I type odd and I insert our vector and I run that, you can see we just get an error message, could not find function odd. So this method that we've used here it requires us to consistently specify the package that the function is coming from, which could potentially be a bit annoying if you're going to be using the function a lot. However, there is a way to load the function so that it is perpetually available to us. We just need to use the library function that we used in the previous videos. We say library, we type gtools, right, the package name, and then we're going to add an argument here, include.only, and then we just, in quotation marks, specify the name of the function. Run that, and now we can use the function on its own. So let's demonstrate that. So if I just type odd and I insert nums, you can see it works just fine. If I insert, value of 13, it says true. If I insert a value of like 12, it says false. Everything works as it should now. And hopefully this goes without saying, but by including this argument, none of the other functions in the gtool package will have been loaded. So for instance, the gtools package has another function for determining whether a number is even or not. And if you try and use that function, it's not going to work. So we say even, and we insert a value of like 12. You can see, could not find function even here. Now, as I said in the previous video on packages, 99% of the time, you're going to want to load the entire package. Not only because it gives you access to all of the functions, but also because sometimes the functions within a package will depend on other functions within that package, or they might depend on functions from other packages. In programming lingo, these are what are called dependencies, because one function is quite literally dependent on another function. And if you haven't loaded everything that the package requires, the specific function that you may want to use might not work properly. So particularly if you're new to R, you should just always load the entire package like so. You should just always say library, gtools, like that. However, because we've already loaded the gtools package using the library command up here, we can't simply run this and get access to all of the functions. And we can kind of demonstrate that, right? If I just try and run even here and I put in a number, you can see it still can't find the function even. Let's maybe clear that. Let's do this just to clean things up a bit. So basically, we've kind of coded ourselves into a corner here. And the question is, how do we get out? Well, one simple option is to just unload the package, that is to say, to unload the gtools package using the function unload namespace. So what we could do is we could simply type gtools like so, and now the package has been unloaded, and then we can reload it using the library function. We could say library gtools like so. And now, if I type even, what you can see is it works just fine. If I use the odd function, that works as well. So let's clean this up. Yeah, and we'll do this here. Just give ourselves some more space. All right. Now, let's suppose you want to see a list of all of the packages that you have installed in your computer's library. How would you go about doing something like that? Well, it's pretty easy. Just need to run the library function with nothing in the parentheses. When you do that, it'll give you a nice big list of everything that's installed. Alternatively, if you want kind of even more detailed information, what you could do is you could use the function install.packages, like so. And when you run that, it gives you a host of information. Now, because my RStudio is kind of zoomed in a lot so you guys can read it nice and clearly, it's kind of hard to actually visualize all of this. So what is often helpful is to use a special function called the view function. The view function is pretty useful. Basically, it will open a data frame in a new window that is kind of got a more traditional sort of spreadsheet look to it. So if we run that, you can see we get a nice new window with a cool little scroll bar, on the bottom and on the side here. And you can actually grab the tab here in RStudio and kind of pull it out. So if you want to look at the entire thing, you can do that. And you can see what we get is we get, the list of the various packages and a bunch of other more detailed information about them. So let's maybe just close that there and clear our console here. Now, it's worth mentioning that packages get updated by their authors every once in a while, particularly when there's new versions of R available. So if you want to check to see if there's been any updates to the packages that you have in your library for the version of R that you're using, what you can do is you can just run the function old.packages. And similar to the install.packages function, this one is usually best viewed with the view function. We can run that, and you can see we get a nice little data frame here. So obviously the column called package tells you the name of the package, and the column called installed just tells you the version of the package you presently have in your library. And of course, repost version shows you the latest version available from the CRAN repository. And if there are newer versions available, it's usually a good idea to update them. And kind of the simplest way to do that is to actually use the function update.packages. So you'd say something like update.packages, like so. And inside this function, it's usually helpful to set an argument called ask equal to false. The reason being, if you don't set this argument, basically you're going to have to manually approve every update, which can be kind of annoying. So you don't need to set this argument, but it's usually much more convenient if you do. So if you run this function, it's going to attempt to update every package in your library that is theoretically able to be updated. And I say theoretically here because sometimes you won't be able to update everything in your library, even if it happens that there is a newer version of a particular package available. And you might think, well, that doesn't make much sense. Why does that happen? And the reason it happens is because a lot of R packages are not actually programmed using R code. Sometimes they get programmed using higher level languages like C++, for instance. And the reason this happens is because these higher level languages essentially allow a programmer to write code that can better optimize a computer's abilities and resources, which is a really nice feature of these languages. But with that comes the drawback of the program needing to be recompiled every time a change is made. Additionally, these higher level languages are working at a much more general or sort of fundamental level of computation. So they tend to lack a lot of the intuitive appeal, I guess, of interpreted languages like R. So interpreted languages are generally a lot less efficient than, these higher level languages, but they tend to be more convenient to use for the purposes that they were designed. And the code that's written for these higher level languages, which some people refer to as compiled languages, the code that's written is usually saved as something called a binary file, which in essence is just a file of ones and zeros. But to use this file, it first needs to be compiled for R. And the reason you may not be able to update a package is because there may not be a compiled version of that package for the version of R that you are kind of currently running. So when this happens, you'll typically see a message, something along the lines of, there are binary versions available, but the source versions are later. Now there are tools that will allow you to compile these, should you want to do that, but to be honest, it's not usually worth the effort. A better approach is to actually just upgrade the version of R that you happen to be using and then reinstall the package. That will usually get you access to the more up-to-date version because the compiled binary will usually be available for whatever the newer version of R happens to be. And for this reason, it's usually a good idea to keep the version of R that you're using up to date. So you can see I'm using version 4.2.2 here, which is, at the time of this recording, a slightly older version. There is a newer one available, 4.3.0. And if you want to update R, all you need to do is quite literally just install the newer version the same way you installed R the first time around when you did it. So you would basically just head over to the R project. Actually, let's do this. You would just head over to the R project for statistical computing. You know, you can see you have the option to download here. Click CRAN, and usually the first option is sufficient, and select your operating system and install accordingly. And when you go through the install process, you just keep all of the defaults. You don't need to uninstall R or RStudio prior to doing it, because the install process will actually keep track of the version numbers. So basically, once you've installed a newer version of R, you can actually just tell RStudio which version you want to use. And I can actually show you how to do that. First, I'm just going to save this code here. So we'll save that. So to switch to a different version of R, you would just go to Tools, Global Options, and then right here on the main page, you can see we have R sessions, and you'll notice it says R 4.2.2. So if I select Change, you can see it gives me a list of stuff here, and I've actually already installed version 4.3.0. So I can select that. And it's going to say you need to quit, reopen RStudio for the change to take effect, which is fine. And the reason I saved this. So let's quit RStudio, and we'll reopen this. And you can see now it says 4.3.0. And you'll notice right here we're getting kind of a kind of cautionary message. Package gtools is required but not installed. And that's because RStudio has recognized that in my code here, I'm using the gtools package. And it also recognizes that that package is not installed. So I would need to install it for version 4.3.0, which I can do pretty easily. So I could run this line, or I could actually just click the little install there. Now, sometimes you may not want to update your entire library. So this updates.package function, the way we're kind of using it here, it's going to update your entire library of packages. But if you don't want to do that, and you just want to update maybe a specific package, then what you can do is you can just literally use the same function, right, update.packages, and specify an argument called old pkgs, which is obviously just short for packages, and input the package name in quotation marks like that. And that will update just that specific package you select. Lastly, if for whatever reason you want to uninstall a package from your library, you can just use the function remove.packages. And inside this, you would just specify the name of the package. So for instance, if I put gtools in here and I run that, you can see it says removing package, takes no time at all.